Question number 15. A chess team has 2 girls, 2 boys. A chess team of 2 girls and 2 boys is to be chosen from 7 girls and 6 boys in the chess club. Chosen का मतलब combinations. Find the number of ways this can be done if 2 of the girls are twins and either both are in the team or both are not in the team. Okay, so we have to select 2 girls, 2 boys in the team, and there are a total of 7 girls and 6 boys, from which you have to select 2 girls and 2 boys. Either you select both the twins in the team or you don't select both of them together in the team. So let's take the case where both are selected, both twins get selected. So this spot will be taken by both the twins. So one of the twins takes one spot, the other takes the other spot. So this is just going to be 2C2. 2 options available, 2 spots available, 2C2. And then for the boys, 6 boys are available and 2 slots are available. So 2C2 times 6C2. Okay. And the next case is that neither of the twins get selected. Twins don't get selected. So then, if you remove the 2 twins from the 7 girls, that's total of 5 girls. So out of 5, 2 will be chosen in the team, and out of the 6 boys, 2 will be chosen in the team. So 5C2 times 6C2, and you add the result. You add the products. You add 2C2 times 6C2 plus 5C2 times 6C2, which gives 165. This is part A. Okay, part B. I'm going to clear this. Okay. Part B. Part 1. The digits of the number 1, 2, 4, 4, 6, 8, 7 can be rearranged to give many 7-digit numbers. 1, 2, 3, 4, 5, 6, 7. It's a question on arrangement, so permutations. Okay, how many 7 digits are even? So if they're even, then this last number can be 2. I'm looking at the even numbers in the given list. 2 or 4 or 4 or 6 or 8. So 1, 2, 3, 4, 5. 5 contenders for this spot. So you can write 5 here or 5P1. And then take away one of the even numbers. How many do we have left? 1, 2, 3, 4, 5, 6. So that's 6 numbers are available for 6 spots. So this is going to be 6 factorial or 6p6. So the answer is going to be 6 factorial times 5 divided by 4 is there twice. So there's repetition. So 2 factorial. So 6 factorial or 6p6 times 5 or 5p1 and upon 2 factorial or 2p2, which gives 1800. Part 2. How many different numbers between 20,000 and 30,000 can be formed using 5 digits from the digits 1, 2, 4, 6, 7, 8? Okay, so we need numbers between 20,000 and 30,000. So that's 5-digit number. 20,000 to 30,000 means that this can only be 2. So that means there's just one contender for this spot. And then how many numbers are left if we take away one of the numbers? 1, 2, 3, 4, 5, 6. There are 6 contenders for these 4 spots. So that's going to be times 6p4. All right, sorry, I was looking at the wrong numbers. These are the numbers given in the second part. So the first spot has one contender only, which is the digit 2. And then 1, 2, 3, 4, 5. There are 5 contenders for the remaining 4 spots. So this is going to be 1 times 5p4. There's no repetition this time, so we don't divide with anything. This gives 120. Part C. Helen has some black tiles, some white tiles, some gray tiles. She places a single row of 8 tiles above her wash basin. 1, 2, 3, 4, 5, 6, 7, 8. Each tile she places is equally likely to be black, white, or green. That means probability of getting a white tile is 1 by 3. Probability of getting a black tile is also 1 by 3. And probability of getting a gray tile is also 1 by 3. Because it says that they're equally likely events. Each tile she places is equally likely to be black, white, or gray. Find the probability that there are no tiles of the same color next to each other. Okay. So we have to find the probability this time, not just the arrangements. So let's say that the first tile is black. Then what's the probability of getting a black tile? It's 1 by 3. Okay. Now, if the first tile is black, then the next tile can be either white or gray. So that's a probability of 2/3. Then this tile will be of a different color than this tile. So like if this is white, for example, then this would be either either black or gray. So black and gray has a probability of 2/3. So times 2/3. Again, now the next tile would be of the other 2 colors except for this one. So then that's again 2/3. Now, whatever is this color, the other tile would be any of the 2 remaining colors, which would be 2 by 3. Now, whatever is this color, the next tile would be not this color, but any of the 2 other colors. So that's 2 by 3. Similarly, you keep doing 2 by 3 till the end. So this is 1/3 times 2/3. 1, 2, 3, 4, 5, 6, 7. 2/3 power 7. However, this was when we said that the black tile is going to be the first tile. What if the gray tile is the first tile? And what if it's the white tile? That's the first tile. Then you redo this entire procedure for green first, and then you redo the entire procedure for white first. But all the 3 procedures will give the same answer. So that's why we just multiply the first answer with 3. So the final answer would be 2/3 power 7 because the 3 and 3 cancel out. The answer would be It's a decimal number, 0.0585. That's the answer. There's another way of doing this as well. Let's take a look at that. So the first tile could be black, could be white, could be gray. So the probability is 3 by 3. Could be white or gray or black. So that's the probability of 3 by 3, which is 1. Then the next tile would be any of the two colors other than the one that's already selected. So that's 2/3. And the next tile would be any one of the two tiles that was not selected in the very previous position. So that's going to be 2/3. Then the next tile is going to be any of the two tiles that did not get selected here. So times 2/3. So you keep doing that. So 3 by 3 is 1. And then you times 2/3 for all the 7 positions. So it's going to be 2/3 power 7 again. And that gives 0.0585. Next question. A small airplane has 14 seats for passengers. The seats are arranged in 4 rows of 3 seats and a back row of 2 seats. See diagram. 12 passengers board the airplane. How many possible seating arrangements are there for 12 passengers? Give your answer correct to 3 significant figures. So there are 14 seats and there are 12 passengers. So for the first one, it's going to be 14P12. Which is 4.3589 into 10 power 10, I believe. Okay, remaining parts. A small airplane has 14 seats for passengers. The seats are, अच्छा ये तो हो गया था, sorry. अब ये करना है. These 12 passengers consist of 2 married couples, Mr. and Mrs. Lin, Mr. and Mrs. Brown, 5 students, and 3 business people. The 3 business people sit in the front row. So we have a business person here, a business person here, and a business person here. The 3 business people sit in the first row. So that is 3 factorial arrangements because 3 people on 3 seats would be 3 factorial or 3p3. So 3 factorial. The 5 students each sit at a window seat. So, and then it says 5 students each sit at a window seat and Mr. and Mrs. Lin sit in the same row on the same side of the aisle. And similarly, Mr. and Mr. Brown sit in the same row on the same side of the aisle. How many possible seating arrangements are there? Okay, so they're saying that the first three seats belong to three business people. We've already drawn that in the figure. Five students sit on the window seat, and these couples sit together on the same side of the aisle. So we know that two of these three would be given to the couples. So maybe one of the couples sit here, maybe one of the couples sit here. So only one of the students gets to sit at the window seat. But we have four window seats here as well. So the students would sit here. Four of the students would sit at the bottom end, and one of the students would sit at the top end. So now let's look at the arrangements for students. So let's start from here. There are five contenders for this spot, four contenders for this spot, three contenders for this spot, two contenders for this spot, and one contenders for this spot. So that's 5 4 times 4 times 3 times 2 times 1, which I'm writing as 5 factorial or even 5p5. So there's times 5p5 or 5 factorial for the arrangements of the students. However, this one student here can also be placed here, can also be placed here. He has three possible options here. So we're going to time 5 factorial with 3. Okay. Now we have couples, Mr. and Mrs. Lin. Let's say they sit here. Mr. Lin and Mrs. Lin. MS or MRS Lin. Okay. Let's say they sit here. So that's going to be 2 factorial arrangements because Mr. Lin can sit next to the window, or maybe Mrs. Lin is going to sit next to the window. So that's 2 factorial. But Mr. and Mrs. Lin can also be placed here. So we again times it with 2 or 2 factorial. 2 factorial is the same as 2. And lastly, we have Mr. Brown and Mrs. Brown. So that is going to be 2 factorial arrangement as well, because Mr. can sit next to the window, or maybe Miss can sit next to the window. So times 2. Okay. What were we supposed to do in this question? Let me read that again. Okay, Brown sits in another row on the same side of the aisle. How many possible seating arrangements are there? Okay, let me check the answer. Three factorial, 5 factorial, 3, 2 factorial, 2 factorial, 2 factorial. Yes, same answer. So that gives 17280. Okay, part 3. If instead the 12 passengers are seated randomly, find the probability that Mr. Lynch sits directly behind a student and Mrs. Brown sits in the first row. Okay. So now the students sit randomly, but we're told that Mrs. Brown sits in the first row. So she's either here or here or here. So that's 3 factorial arrangements, 3 factorial arrangements or 3p3. Just give me a second. Sorry, it's not 3 factorial. It's not 3 people sitting on the front. It's one person sitting on one of these 3 seats. So there's one person who has to sit in any one of these 3 seats. One person available for 3 spots. So it's going to be 3P1 and not 3P3 like I incorrectly said earlier. So it's going to be 3P1. And it says Mr. Lin since sits directly behind a student. So let me just say that, for example, the student is sitting here and then Mr. Brown sits here. So this would be 2 factorial. No, in fact, it's not 2 factorial. It's the student has to be at the front and Mr. Brown has to be at the back. However, this has 5 possibilities because there are 5 students. So any one of those students is sitting over here. So then that's going to be 5 or 5P1. So I'm going to multiply this with 5 or 5P1. Let me write 5P1. Okay. Times. Now this group of student and Mr. Brown behind him can also be located on these 2 seats, student and Brown, or these 2 seats, student and Brown. So basically, student has to be at the front, Brown has to be right behind it, student and Brown. So that's one location for this pair, second location, third location, fourth, fifth, sixth, seventh, eighth, ninth, 10, 11. So there are 11 spots available for this practice. So it's going to be, in fact, it's not 11 spots. I think it's 10 spots. Did I miscount, calculate it? Let me just see again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 spots. Okay, so times 11. And next, it's going to be times. So we've made Mr. Brown sit somewhere. We've made one of the students sit somewhere. And we've made front पे कौन था? Okay, so sorry, it was Mr. Lin who sits directly behind uh, the student. So this should have been L. बाकी सब कुछ ठीक है, but there was Mr. Lin sitting behind a student. So then we've made Mr. Lin sit in one of these seats. So अब कितनी seats रह गई? 14 seats हैं. 14 में से 3 seats निकाल ली. So that's going to be 11. So 11 seats are left. And how many people are left? Originally, there were 12 people. So 12 minus 3 is 9. So now there are 11 seats available for 9 people. So it's going to be 11P9. And you have to find the probability. We're finding the probability. So in the denominator, you write the total number of arrangements which we had already found in part 1, I believe, which was 14P12. So in the denominator, you write answer of part 1 divided by 14P12. So that's 0.0687. Just give me a second, मैं आ रही हूँ.